So I am Avnish Parmananka. I hail from Kolkata. I have done my schooling over here only. My B.Tech was in Electronics and Telecommunication from Kalinga Institute of Industrial Technology, Bhubaneswar. My overall CGPA was 9.45, and my keen interest in B.Tech curriculum and my hard work even paved a way for me to achieve merit scholarship by securing third position in overall electronics branch in fourth semester. And my BTech project was on the topic image processing and machine learning algorithm.
Okay, so when did you graduate it?
I have done my graduation in 2021, pass out.
So what you're doing since last 2 years?
So, sir, 1 year I have taken the experience like in the IT sector. Like I worked in Wipro for 1 year, but due to my keen interest in my core subjects, I decided to appear for GATE, and so for that reason, 1 year I prepared for the GATE, and today I am here now.
Okay, what was your GATE performance?
My GATE score was, sir, 555.
Okay, so what do you mean by the core interest? Can you define it a bit?
So, sir, like during my BTech curriculum, like I find like all the electronic subject very interesting, and specifically, sir, communication, because I find it to be more practical oriented, and I can see around myself like what is happening in the communication. So I wanted to work in industry in that domain itself, like where I have honestly studied for the 4 years. So I want to practically work in that domain. So for that reason, I wanted to appear for the GATE, and I even want to know more about this subject. So that's the
Okay,
reason.
what you have done in your project? Tell me in brief.
Okay.
And which
So
algorithm you have used?
yes. So, sir, it was like two-step procedure in our which we have implemented in our project. The first part was the extraction of features from the images. Like we have basically collected the chest X-ray scan images from the internet resources of two cases: COVID cases, COVID pneumonia cases,
No,
and non-COVID.
tell me about what algorithm you used for the extraction of information.
Okay, so we have used like histogram equalization, and we have even used like filters to process the image, and we have
Which
extract
filter? Which kind of filter?
we have used median filter twice to better the better the image, to improve the quality of the image, and then we
Okay,
have
there are
used.
two terms. One is noise in communication, as you are interested in communication, and one is noise in image, right? What is the difference between these two?
So the noise in the communication, it's like when we are communicating, like when we are transmitting any message like from one place to another, the uh, the the unnecessary components which are added in the channel, that can be termed as the noise in the communication. So it can be through the channel, or during the channel transmission the noise can be there, or there can be like external and internal, there can be two noises in the communication basically. But for the image, the noises are basically the feature um, it's the pixel quality, we can say, like the pixels which are not uh,
So do you think that you told you use the median filter? Median filter gave a better performance for the noisy images?
yes, sir, the reason was to improve the quality, so we have taken the median
What is the
filter.
meaning of improving the quality? If I give you my image and I say improve the quality, what do you mean as a layman person improving the quality? Tell me that. Have you worked really on the project? What was
Yes,
okay?
my part was, sir, basically related to image processing. I have worked
Okay,
on
fine.
that.
Your part was image processing. Can you tell me what are the subsequent stages of the image processing?
So
If you want to tell some new person who don't know anything about image processing, obviously you will not directly tell him about algorithm and the software and tools, right? So you will tell him first layman language by drawing some diagrams, schematic on the copy. Can you understand? Can you let me understand the same process? If I come to you, Avnish, I want to understand what is this image processing. How you will teach me this? That I want to understand.
So it is basically extracting the components, like if we are given with any image and we have to like if we the basic thing starts with like the sampling and quantization is also done in the image, like to compress the image we basically do the sampling of the images, and to make it like uniform in the intensity, we do the quantization. Like there are, like if we are having 256 cross 256
Okay,
image.
these are very technical term. I'm getting my point. Tell me any practical example where image processing is very effective. Tell me in practical example in real world scenario which I might have seen and which you might have seen. Tell me any practical example where image processing is working effectively.
So
You getting my question or not, right?
yes sir,
What you're
yes sir.
telling me that is a bit technical thing. I can understand that, right? But obviously you have interest in image processing. You have done the image process. It's not like that tomorrow morning you wake up and you told that okay, I want to do image processing. You might have created interest in that, right? So can you tell me any real world applications where image processing is involved?
So sir, basically like in the uh, for taking the satellite images, like for determining the vegetation of any place. So basically it is known as Landsat images. So there it is actually image processing is used. Like we are so here it is basically through the image processing they can determine whether like how much area is the vegetation, how much area it's like water body. So there are different channels through which it can be determined. Like if we want, if we are interested in knowing the water bodies, it is passed through different channel to like there is something different
या
which we are.
सिंपल सी बात मुझे एक बात बताओ फेस डिटेक्शन हम इतनी जगह पे यूज करते हैं वो इमेज प्रोसेसिंग नहीं है क्या
Yes sir.
तो इतना लंबा सैटेलाइट उसमें क्यों जा रहे हो बताइए हैं टेल मी सिंपल थिंग व्हाई यू वांट
Sir, compression of image is also one of the thing
फिर
which we do in the.
प्रैक्टिकल एग्जांपल बताओ ना जो हम डेली लाइफ में यूज कर रहे हैं आप भी यूज कर रहे हैं मैं भी यूज कर रहा हूँ व्हाई वी आर गोइंग फॉर सैटेलाइट वेजिटेशन
Yes,
दीस
sir.
आर थिंग्स
Yes, sir.
डेफिनेटली दीस आर थिंग्स
Yes, sir.
okay so you have keen interest in the communication right
Yes, sir.
so I'm going to ask you something from communication coming to your interest do you know what is noise equivalent bandwidth
Noise equivalent bandwidth. So, like like N naught is equals to KTB. Is that the thing, like, sir, which
that is
I,
power spectral density
yes,
and not by 2 kTB is output power noise power that is a noise power
yes.
noise equivalent bandwidth.
So there is one relation, sir, with channel capacity where it is relating with the bandwidth, like SNR and bandwidth relation.
Okay, although that is not answer for this. Okay, fine. Tell me that relation. What is that relation?
So that is channel capacity C is equals to B, which is the bandwidth, into 1 plus C into B into log of 1 plus S by N, where S by N is the ratio, it is not in
What is the
dB.
base of log?
Base of log is base 2.
If I make here bandwidth infinite, what will be channel capacity?
Bandwidth is infinite. So sir, here according to this, if we make the bandwidth infinite, here the channel capacity is infinite, but practically we have to band limit our signal. So
चैनल
that,
कैपेसिटी इनफाइनाइट होगा क्या पक्का तो मैं पढ़ा नहीं है यार कम्युनिकेशन इंग्लिश है सिग्नल टू नॉइस पावर वो भी तो फंक्शन ऑफ बैंडविड्थ होगा नॉइस पावर फंक्शन ऑफ बैंडविड्थ नहीं होता क्या आपका फंक्शन नहीं बन जाएगा मैथमेटिकल फंक्शन y इज इक्वल टू x log of 2 into 1 plus सम कांस्टेंट अपॉन सम x फंक्शन लिमिट लगाओगे x टेंड्स टू इंफिनिटी तो क्या इनफाइनाइट हो जाएगा सारा
अच्छा, this is 1.44 SN, वो आता है शायद चैनल
एलटीई
या
सिस्टम के बारे में पढ़े हो
सॉरी
एलटीई सिस्टम के बारे में पढ़े हो क्या
LTI.
क्या
यस सर, यस सर.
कोई भी लेट अस सपोज तुम्हारे पास एलटीई सिस्टम है उसमें मैं पीरियोडिक इनपुट देता हूँ उसमें जो आउटपुट आएगा वो क्या आएगा, पीरियोडिक आएगा, पीरियोडिक आएगा?
Sir, it will be periodic output only.
टाइम पीरियड क्या होगा, सेम होगा, डिफरेंट होगा?
Time period will be also, it will remain same.
आर यू श्योर?
So basically LTI system, we do the convolution and so for the relation of YT, it will be one like y of t into x of t, h of t minus t, tau. So yes, sir.
बट तुम जो रीजन दे रहे हो वो तो मुझे कुछ अलग ही लग रहे हैं, बस आंसर तुम्हारा सही लग रहा है मुझे, है?
Sir,
जिस
because LTI system is basically a linear and time invariant system. So, sir, it is actually like there are two things which is happening in this thing. One, there is a time shifting, like, and another it is scaling by a constant factor, and then we are adding all the signals. So this is the basically the property of LTI system. So there is no relation with the time period which will affect the LTI system.
ओके, अगर तुम्हें किसी एलटी सिस्टम की एनालिसिस करनी है, व्हाट आर द डिफरेंट वे हाउ यू विल डू एनालिसिस?
Sir, the
What
basic
are
thing
the
is,
different modes of doing analysis? Tell me.
sir, using the impulse response, I believe that we can tell
Yes, that
everything
is one
about.
of the other.
Using impulse response, we can tell about all the features. Then other way for LTI system,
Can we use state space variable, state variable representation?
state variable
Can
representation.
we use
Sir,
differential equation representation?
yes, sir. A differential equation we can use, and state space also, sir, we can use. But why should we move in that complex thing when we can do it by simple way? Because
I asked
initial
what are the multiple way. I didn't ask
okay,
which is the best way.
okay, yes, sir. So yes, sir. Definitely, we can use state space also.
Okay. Have you studied random variable?
Yes, sir.
Can you draw the Gaussian PDF on your copy?
Yes, sir.
Do it fast, please. ये दिखा, तुमने फिल्टर लगा रखा है, शायद दिखाई नहीं देगा इसको।
हाँ सर, वो ठीक है।
ओके, अगर मैं इसका मीन 1 कर दूं, सॉरी मीन 0 कर दूं और वेरियस 1 कर दूं, तो इस करव को क्या बोलते हैं?
Normalized PDF, normalized Gaussian PDF.
बनाइए इसका डिस्ट्रीब्यूशन बनाइए अंडर दैट केस। ओके
Sir, it will be shifted to origin.
ओके फाइन यार, देखो लेट मी गिव माय, ओके फाइन यू कैन कीप इट डाउन, लेट मी गिव माय फीडबैक देन विनय सर विल कंटिन्यू विद यू। देखो यार क्या चीज है, मैंने आपको कई बार बोला है कि बेसिक कंसेप्ट पे बिल्कुल क्लियर रहा करो, राइट? And when you are answering, although you answer some of the question, but you are not looking confident enough. It seems like you're trying to guess them, and they are the very basic. I hardly I haven't I asked any difficult question, any kind of question which you know nobody have listened. All the question was some basic. If you draw ideal low pass filter, obviously there will be what is transfer function, how it will goes. It will be constant, it's system function, right? From cutoff frequencies. If you draw practical, it will be not a constant, it will be some practical variation will be there. Is it clear?
Yes,
So
sir.
obviously if you pass some noise through low pass filter, obviously the output noise power will be different. But if you pass the same noise power through the practical, obviously the output will be different. Is it clear? But
Yes,
if
sir.
you want to equate the noise power, then what bandwidth of that practical low pass filter is required? That is the practical significance of the noise equivalent bandwidth. Is it clear or not, right? Okay.
Okay.
You need to demonstrate it by using a proper example. And second thing, when it comes to channel capacity, I was asking you this thing, but you start remembering channel capacity and suddenly you spoke about that thing. That was nowhere related to it. But anyways, if you just remember that, that's why I ask you question. If I make bandwidth infinite, what will be channel capacity? It can never be infinite, right? So it's some practical limitation there.
1.44 some वैसा
वो
कुछ.
चीजें आपको ध्यान में रखनी है। और दूसरा चीज है इमेज प्रोसेसिंग में आपसे प्रोजेक्ट इसलिए पूछा क्योंकि सिग्नल सिस्टम से रिलेट करता है। उसमें आप एल्गोरिदम के बारे में क्लियर रहो, क्या एल्गोरिदम आपने यूज किए हैं और प्रैक्टिकल रियल वर्ल्ड एप्लीकेशन में कहाँ पे यूज हो रही है, उसके फंडामेंटल पे क्लैरिटी रखो। मैंने आपको वो चीजें नहीं पूछी जो तुम पढ़ के आए हो, मैंने एक दो चीजें सिंपल पूछी कि रियल वर्ल्ड एप्लीकेशन बताओ, तुम पता नहीं कहाँ सैटेलाइट में किधर चले गए। तो जो डेली देखो कि जब भी किसी को कोई चीज एप्लीकेशन में बतानी, वो बताओ जो तुम वो और मैं प्रैक्टिकल वर्ल्ड में यूज कर रहे हैं। उससे क्लैरिटी जाता है कि ओके यू अंडरस्टैंड, यू रियलाइज एंड यू थिंक ओवर द सराउंडिंग प्रॉब्लम्स, नॉट ओनली जस्ट यू रीड फ्रॉम द बुक्स। कई बार हम ऐसे एग्जांपल देना स्टार्ट कर लेते हैं जो ट्रेडिशनल एग्जांपल होते हैं किसी बुक के। तो इन चीजों को ध्यान में रखो। ओके,
Okay,
गेटिंग
sir.
क्लियर?
Yes, sir.
तो नेक्स्ट विनय सर विल कंटिन्यू विद यू।
Hello, Avnish.
Yes, sir.
Okay. Okay, Avnish. So tell me first of all, आप कौन-कौन से सब्जेक्ट प्रिपेयर कर रहे हैं? As you are going for a signal and communication. इसके अलावा कुछ और पढ़े हैं आपने?
Sir, 3 subjects I have prepared: linear algebra, signal system, and digital communication.
Okay. First of all, what is the Fourier series?
So, sir, basically, Fourier series tells us like if we are having any periodic signal, so it can be represented like it can be represented as the exponential. It can be for any periodic signal, we can represent it by the which are harmonically related to each other and which is orthogonal to one another. So any signal can be represented by the like uh, summation of these complex exponentials. So that is what actually the Fourier series tells us.
Summation of these complex exponential.
Yes, sir. Weighted like
आपने आंसर हम्म Okay, you told that orthogonal. What is the meaning of orthogonal?
Sir, mathematically, we can say that two signals are orthogonal if like integration of x, like if we are considering two signal x1t and x2t, so they are said to be orthogonal if their integral from minus infinity to infinity gives us zero result.
Okay, now suppose you told the definition of Fourier series. I want what is the practical use of Fourier series? Why we study the Fourier series?
Okay.
So
Yes, sir. So, sir, basically, our objective is to determine the output of LTI system. So, like what we are doing, we are having any signal XT if we are having any signal, and we want to know the output of the system, like what will be the output. So, it is a easy way using Fourier series. We can easily tell the output of the LTI system because here, like it is basically we are expressing the signal as exponential harmonic exponential. So as we know that if we are giving any signal to the LTI system which is exponential, the output will be also same exponential multiplied by some scaling factor. So due to this property of LTI system, we are representing the signals in terms of like uh, superposition of basically all the complex exponentials or sinusoids.
Avnish, what was the question?
Why are we using the Fourier series?
आपने जो बताया वो एग्जैक्ट टू द पॉइंट था। आई थिंक आपको जो आइडिया है, जो आपको पता है, वो आप उसमें ऐड करके होता है तो क्वेश्चन का आंसर जो पूछा जाए उससे रिलेटेड हो। हाँ ठीक है, ऑल द थिंग्स आर रिलेटेड, बट आपको उससे टू द पॉइंट है तो ज्यादा बेहतर है। ओके विनी, नेक्स्ट मूव। आर यू अवेयर अबाउट द आरओसी?
Yes, sir.
हाँ, व्हाट इज द आरओसी? फर्स्ट ऑफ ऑल डिफाइन आरओसी।
So Sir, basically, for like when we are taking any transform like Laplace transform or Z transform, basically our objective is that the signal should converge to a point. So the region, it is basically ROC tells us about the region like where the signal will finally converge or where the integral will get finite, so that we can get the proper transform. So the region which is defined by this thing which will actually make the integration finite. So that is the region of convergence, like in which region the signal
Okay,
will actually converge. That is basically the
okay.
idea.
So means we find the ROC where the signal is converged. And what is the meaning of converge? Where the integration is finite.
Yes,
That
sir.
is the things. Okay.
Yes.
Okay. Where the integration is finite. So can you suppose write down the signal e to the power minus 80 ut?
Yes, sir.
So how to find the ROC for this signal?
So
स्टेप पता है, कैलकुलेट मत करें, जस्ट मुझे
okay,
ओवरऑल आइडिया चाहिए हाउ यू अंडरस्टैंड द आरओसी कंसेप्ट.
okay. So sir, first we will take the Laplace transform of this signal, and we will check, since this is ut, so basically this is right sided signal. So after equating, after finding the pole, we can see tell from the right sided sequence that the ROC will be towards the right of the pole. So that way we can say, like, first we will find the Laplace transform, we will do pole zero map plotting, and by the property like
नहीं,
ut is.
ये तो हमने अभी याद कर लिया. ओके, 1 मिनट, ये तो हमने याद कर लिया. सपोज दिस सिग्नल इज राइट हैंडेड, देन आरओसी विल बी द ग्रेटर देन दिस.
Yes, sir.
मैं जानना चाहता हूँ हाउ वी फाइंड द आरओसी, हाउ वी फाइंड दैट द सिग्नल विल बी कन्वर्ज इन दिस एरिया. दिस इज द
Okay,
कंसेप्ट.
okay. So
कैसे पता करेंगे? आपको याद है कि अगर माइनस यूटी होता तो लेस देन कर देते, ग्रेटर देन कर देते. ओके.
yes, sir. So the conventional approach will be, sir, like we will be using the standard formula to find the Laplace transform, like x of s is equals to x of t into e to the power minus st, and we will substitute s is equals to sigma plus j omega, and then we will try to find the value of sigma for which this integration will basically give us finite result.
So how to find this value for the finite result? This is the question. How to find the value for the finite result?
Okay. So, sir, like
Okay,
while
suppose.
solving the
हाँ,
integration.
yes, इंटीग्रेशन सॉल्व करके वैल्यू निकालते हैं.
Yes, sir.
अच्छा, चले नेक्स्ट क्वेश्चन पे आते हैं. सपोज इन दिस क्वेश्चन e to the power minus 80 ut, you have a equal to -2. ठीक है?
Okay.
Then signal will be stable, unstable, causal, non-causal. Tell me about the signal.
So, sir, this is actually causal system because we are having ut, so it will be only the for a time greater than 0. And for telling about the stability, we will say that this is not a stable system because for time greater than 0 we are having like the infinite bounded signal. It is not finite in amplitude. It will be
Okay.
exponentially increasing curve in the right side.
Okay. What is the VCO?
VCO.
Yeah.
So, sir, basically VCO is voltage controlled oscillator. This is actually used in FM modulation, basically, where the amplitude variation of any message signal is converted to frequency variation. So that is basic principle for VCO.
Amplitude variation converted into the frequency variation.
Yes, sir.
What is the full form? Voltage controlled oscillator. Okay.
Yes.
Hello.
Hello.
Any other method for the FM generation?
Yes, sir. We are having this thing. PLL we are having.
What is the full form of PLL?
Phase logged loop.
कैसे काम करता है? ड्रॉ द नॉट ड्रॉ द डायग्राम, ऐसे ही समझाएं कैसे हाउ इट विल वर्क।
Sir, I am not having the proper, I can't remember the proper steps for this thing, but I can tell it like as far as I remember, like when we are having any input to the this PLL, so it will check for actually like uh, the variation in the frequency phase. I
ओके
think that.
ओके लेट्स कंक्लूड, ओके लेट्स कंक्लूड इंटरव्यू।
Yeah,
तो मैं अपना फीडबैक देता हूँ। फर्स्ट ऑफ ऑल कि क्वेश्चंस जो आपसे पूछे जाए, है ना, गिव द आंसर। अगर आपको आइडिया है तो गिव द आंसर टू द पॉइंट, आप जो उससे रिलेटेड आंसर दें। आपको मैंने 2-3 क्वेश्चन पूछे, उसमें आपने जो है उसको रिलेट करके दिया है, व्हाट यू नो उससे आपने रिलेट किया है, ठीक है। तो दैट इज ओके, इफ यू डोंट नो दैट ओके, बट आप उनसे बोले कि सर आई एम नॉट अवेयर, आई एम नॉट श्योर अबाउट द एग्जैक्ट व्हाट इज द एग्जैक्ट आंसर, ठीक है, कैन आई गेस, कैन आई ट्राई, ये बहुत जरूरी है, ठीक है। आप उसको ऐसे अपन जैसे कॉलेज इंटरव्यू देते हैं, ये थोड़ा सा वहां पर नहीं हो जाता, स्पेशली इन आईआईटी लाइक, और है ना, पहली थिंग। सेकंड थिंग, यू हैव द कॉन्फिडेंस, आपका जो बोलने का तरीका है दैट इज ओके, है ना, एक्सप्लेन करने का तरीका वो भी ठीक है, कॉन्फिडेंस है। बट जब क्वेश्चन नहीं बनता है तो उसको मैनेज करना, दैट इज ऑल्सो अ वेरी इंपॉर्टेंट थिंग। जो चीज पता है उसमें तो कॉन्फिडेंट है, जो चीज नहीं पता हाउ टू हैंडल द दो चीज, वो इंपॉर्टेंट है। तो कभी तो उसको थोड़ा उस पर भी काम करें, है ना। और जैसे कि आप कम्युनिकेशन सिग्नल इस ब्रांच में जा रहे हैं, तो थोड़ा सा कम्युनिकेशन की बेसिक बेसिक चीजें, पीएलएल, बीसीओ, इसको एक बार और ये सब चीजों को जरूर देखें, ठीक है अपनी,
okay.
ठीक है। ओके, दैट्स ऑल फ्रॉम माय साइड,
सर
बेस्ट
वो
ऑफ।
वाले क्वेश्चन का आंसर क्या था, आप एक बार बता सकते हैं, जिसमें आप एलटीआई सिस्टम का पूछे थे, फोरियर सीरीज का वो वाला।
व्हाट इज द प्रैक्टिकल यूज ऑफ फोरियर सीरीज?
यस सर।
ओके, तो सबसे पहले हम फोरियर सीरीज क्या है, फोरियर सीरीज जो हम पढ़ते हैं, तो फॉर द पीरियोडिक सिग्नल, फर्स्ट ऑफ थिंग, सपोज यू हैव द एनी पीरियोडिक सिग्नल, so you have to analyze the periodic signal, so when we have to convert any of, ये जरूरी नहीं कि साइनोसोडल हो या ट्रायंगुलर हो कि या वो रेक्टेंगुलर हो, कोई भी पीरियोडिक सिग्नल है, फर्स्ट ऑफ ऑल वी हैव टू कन्वर्ट पीरियोडिक सिग्नल टू मैथमेटिकल वे, ठीक है। तो पहले मैथमेटिकल उसको कन्वर्ट करने के लिए हम उसे फोरियर सीरीज का यूज करते हैं, फर्स्ट उसका प्रैक्टिकल यूज है। देन वी सी कि उसमें जो हमारे हार्मोनिक्स का इफेक्ट क्या है, और आप जानते हो कि जो हमारे हार्मोनिक्स होते हैं, सेकंड हार्मोनिक, थर्ड हार्मोनिक, ऑल आर अनवांटेड, हमको नहीं चाहिए, तो उनका इफेक्ट क्या है वो हम देखना चाहते हैं, वो मैग्नीट्यूड वाइज देखते हैं कितना इफेक्ट है। हालांकि वी नो दैट जैसे जैसे हार्मोनिक्स बढ़ते जाते हैं क्या होता है, उसका इफेक्ट घटता जाता है ना, तो वो हम देखना है। तो दैट ये हमारे दोस्त प्रैक्टिकली, ओके
ओके।
ठीक है, ओके, एनीथिंग।
सर एक चीज और
ठीक,
पूछना था कि
जल्दी
लाइक,
बताइए, बच्चा आ गया, नेक्स्ट नेक्स्ट
ओके
स्लॉट है हमारा, हाँ जल्दी बोले।
सर, ये इंट्रोडक्शन में शुड आई मेंशन अबाउट द विप्रो वाला वर्क एक्सपीरियंस, बिकॉज आई डोंट हैव एनी आइडिया लाइक व्हाट आई हैव डन, बिकॉज आई वाज बेसिकली प्रिपेयरिंग फॉर द
You
गेट।
can mention, yeah, there is no point, right? Otherwise, else they will ask, they will take it negative way that what you were doing for 2 days, okay, for 2 years. Is it
ओके।
clear? So
अच्छा।
it doesn't matter. They will not ask much. They can ask you that what was your profile there. So you must have bit of learning. Obviously, if you have worked actually, you might be knowing what you were doing there, right? And get ready for the question if you will mention. What was your profile basically?
सर मेरा पाइथन पे था, और बेसिकली मैं ज्यादा टाइम लर्निंग पे था, तो उसमें मैं लर्निंग किया नहीं
आप
था
उसको
मैंने।
ये बोल सकते हैं कि सर इट वाज बेसिकली इन बिगिनिंग 6 month इट वाज काइंड ऑफ अ ट्रेनिंग प्रोग्राम वेयर वी गॉट टू नो अबाउट डिफरेंट डोमेन्स एंड प्रोजेक्ट ऑफ विप्रो एंड आई वाज इनटू प्रोजेक्ट्स मैनेजमेंट समथिंग लाइक दिस, ओके। पाइथन बताओगे तो पाइथन में बुरी तरह से ग्रिल कर देंगे, एंड पाइथन इज अ वेरी इंपॉर्टेंट एस्पेक्ट फॉर कम्युनिकेशन एंड सिग्नल
हाँ
प्रोसेसिंग
सर,
टुडेस वर्ल्ड,
इसलिए
ओके।
मेरे को
अगर
थोड़ा
पाइथन के ऊपर कमांड नहीं है तो सिंपल पाइथन
नहीं
मत
है सर,
बताना, आप
भूल गया
सिंपल
वो
बोल
तो।
दीजिए कि सर आई वाज देयर एज अ प्रोजेक्ट इंजीनियर, और प्रोजेक्ट कुछ प्रोजेक्ट से रिलेटेड प्रोफाइल बना देना, एंड आई वाज इन्वॉल्वड इन द क्रॉस फंक्शनलिटी डोमेन, राइट? So where my role was bit of non-technical, that's why I was also not satisfied with the role. आप ऐसे बता दीजिएगा इसको, okay?
अच्छा, ओके सर।
Okay, and Avnish, you may leave, okay?
ओके, थैंक यू सर।
Okay.